In this lecture, I want to introduce how to perform beta analysis to everyone. The beta value is to measure a stock price's volatility. If a stock has a larger beta value, that means the stock prices are more volatile, which further means the stock prices are more likely to change dramatically. Let's see an example. Suppose we have stock A and B. As you can see on this slide, after 3 days, both of the stocks increased by about 10%, right? As you can see on this slide. However, the stock price changing processes are different between A and B. Stock A changed more dramatically. On day 2, stock A dropped by 20%. And then on day 3, stock A increased by almost 38%. Stock B changed more steadily, right? On day 2, stock B increased by 4%. On day 3, it increased by almost 6%. We have to develop something to measure the difference in the stock changes, right? To show stock A changes more dramatically than stock B. We use the beta value to show the volatility of each stock price's changes. Here are some rules about the beta value. Later in this lecture, I will show everyone how to calculate the beta value. But we have to remember some rules about it first. When we compare stock A to stock B, and then we find out the stock A's beta value is greater than 1, that means stock A is more volatile than stock B. That means stock A stock prices are more likely to change dramatically than stock B. If stock A's beta value is less than 1, then stock A is less likely to change dramatically than stock B. Of course, if the beta value is 1, stock A and stock B have similar volatility. Here is a question. Why do we care about the beta value? Or why do we care about the stock price changes? The beta value is a great factor for investors to consider when we take a different investment strategy. Let's say I'm an investor who's willing to take more risk. I would like to choose a stock with a larger beta value. Why? Because I can see more investment opportunities. Let's say I sell stock A on day 1 at the highest point, and then I bought stock A again on day 2 at the lowest point, and then I sold stock A again at the highest point on day 3. Then basically, my return rate is not 10% in 3 days. It would be about 60%, right? But not all investors would like to take a risk. Some more conservative investors would tell the risk takers, congratulations if you can take such an advantage of the market opportunities. However, I'm not going to ride the roller coaster. I want to keep my money safer. So I would prefer the stocks that change more steadily. For instance, stock B. If the stock increases, I'm not going to get a lot of profit. However, I wouldn't lose a lot of money if the stock decreases. For those conservative investors, stocks with a lower beta value would be the preferred option. This is the purpose of a beta value. It provides decision support information to the investors. Next, I want to use a Facebook stock and a Twitter stock as an example to show you how to calculate the beta value. Let's go to Yahoo Finance. In the top search bar, let's search Facebook stock first. Let's type in FB. This is a ticker for Facebook stocks. If you don't know the ticker, simply type in Facebook, and then the first one would be the stock ticker, FB. And then click FB. On this page, click historical data. Let's download some example data. Let's say we want to download the stock prices for Facebook from January 2nd, 2017 to June 1st, 2017. I showed you how to specify the time frame, right? Click this little triangle in the starting date. Let's type in 1/2/2017. And then in the ending date, let's type in 6/1/2017. And then click Done. Next, click Apply. And then click Download Data. Let's just save this CSV file on the desktop. It's easier to find. Next, let's download the stock prices for Twitter. In the top search bar, let's type in TWTR. That's the ticker for Twitter. If you don't know, simply type in Twitter. And then you will find the TWTR, right? Click on this one. This is the ticker for Twitter. Make sure you are on the Twitter page. And then change the time period to the one as same as the one for Facebook. It should be 1/2/2017. The ending date should be June 4/1/2017, and then click Done. And then click Apply. When you calculate the beta value, make sure the time periods are the same for both stocks. And then click Download Data. Similarly, we save this CSV file on the desktop. Next, let's go to Jupyter platform. Let's go to try.jupyter.org and then click Datasets folder. And then click another datasets. This is the place we should upload data to. Click Upload and then choose the 2 CSV file. When you choose the second one, you can press and hold the Control key, and then you are able to select both of them at the same time. And then click Open. And then you can click Upload one by one to upload both of the files. Make sure they are uploaded to the datasets folder. As you can see here, fb.csv, and then scroll down to the T row, it should be TWTR. And then click Jupyter, this icon. Let's start the Python program. Let's go to Welcome to Python, and then create a new script cell. Similarly, we have to import the pandas library. Let's type in import pandas as PD. And then we need to import the Facebook and the Twitter.csv file into Jupyter. Also, we want to transform them into the time series data. Let's create one variable called FB stock to hold the time series data. It should be pd.read_csv. These are just some routine comments, right? We should be very familiar to them. Inside of the parentheses, the first parameter should be datasets /datasets/fb.csv. Notice that FB are in uppercases. And then a comma. The second parameter should be parse underscore dates equals to true. And then another comma. That means we want to analyze if there are some dates data in this data frame. Next will be index underscore col equals to 0. This means the first column holds the date data. We want to use it as the index for this data frame. Let's take a look at this data frame. Let's type in FB stock and then click the Run Cell button. This is the data set. Start from January 3rd. I think January 2nd in 2017 is a holiday. That's why we don't have the data. So it starts from January 3rd. And the ending date should be June 1st. Totally, there are 104 rows of data in this data frame. Next, we can do the same. Let's remove FB stock. Let's do the same to import the Twitter data. Let's simply copy FB stock statement and then just make some modifications. Let's create a new variable. Let's call this Twitter stock to hold the Twitter data. And then in the data sets, instead of using FB, we should use twtr.csv. This will be the Twitter stock data. Let's take a look. Twitter stock. Let's click the Run Cell button. It also starts from January 3rd, and then the ending date should be June 1st. We also have 104 rows of data for Twitter stock. Notice that in each data frame, we only have the close price, right? We don't have the percentage of changes every day. If you look at the PowerPoint, when we calculate the beta value, we should compare the changes of the stock prices, right? But in the existing data frame, we don't have the changes. We don't have the percentage of changes. So what should we do? We need to build a Python function to calculate a stock daily price changes. In the stock market, this is how we calculate the daily changes. We use the current closing price minus the previous closing price. We get a difference, right? Then we use the previous closing price to divide the difference we just get. This will be the daily change on the current day. Let's say we want to say how Twitter stock changed between January 4th and January 3rd. So we use the current closing price, 16.86, minus the previous closing price, 16.44. That will be 42 cents difference, right? Or $0.42. And then we want to use the previous closing price, 16.44, to divide the 0.42 difference. This will be the daily change for Twitter on January 4th. This is how we calculate the daily change. Let's implement this mathematical equation in Python. Do you still remember how to write a function in Python? Let's remove Twitter stock and then let's type in def. This is a keyword showing that you want to write a new function. Let's give a name to this new function. Let's call this stock change. And then parentheses. Inside of the parentheses, I want to type in prices. I want to use prices to represent a parameter. This also means this function we are building can accept the user's input. We want to give a bunch of closing price for Twitter or Facebook to this function. And then inside of this function, we want to calculate the daily change percentages. After the ending parentheses, let's type in a colon. This means we are about to write the contents for this function. Inside of this function, I want to type in return. After return, I want to implement the mathematical equation. Let me write down the statement first, and then I will explain what they mean. I want to type in a set of parentheses, and then between the parentheses, I want to type in prices minus prices dot shift. After shift, I have another set of parentheses. Notice that I have the inner parentheses inside of the outer parentheses. Between the inner parentheses, I want to type in 1, and then after the outer parentheses, I want to type in a / and then type in prices dot shift, and then another set of parentheses, and then type in 1. What does this mean? First, we need to know the shift function. Shift function means we want to refer to the value in the previous cell. Let's say we want to give all values in the close column to our function. Price will refer to the current closing price. Price.shift1 will then refer to the value in one cell before. That will be the previous closing price. By doing this, we can refer to the current closing price and then previous closing price over and over again. Finally, we get all the percentages of changes. We use return to return the value as a final result from the function to the next variable. Let's take a look at how we use this. Let's say I want to use this function to calculate Twitter daily changes. Then I will create a new variable. Let's call this Twitter changes equals to stock change. Between the parentheses, I want to use Twitter stock and then square brackets. Between the square brackets, let's type in two double quotes. Between two double quotes, let's type in close. This means I want to refer to all values in the close column in the Twitter data frame, right? After I access to this data, I want to give this data to the function I just built. And then I use the function to get the daily change percentages. Finally, I give these changes to a new variable called Twitter changes. Let's take a look at Twitter changes. Let's click the Run Cell button. This report shows the percentages of changes for Twitter. Compared to January 3rd, Twitter increased by about 2.5% on January 4th. This is a real number with decimal points. If you transform this number into a percentage, it's about 2.5%, right? Compared to January 4th, Twitter increased by 1.3% on January 5th, and so on and so forth. We can also use the function we just built to calculate the percentages of changes for Facebook. Let's create a new variable. Let's call this FB changes equals to stock change. This is the function name we just built. Parentheses. Now we need to access to Facebook data frame, right? It's stored in FB stock. So between the parentheses, let's type in FB stock. And then square brackets. Between square brackets, two double quotes. And then let's type in close. We want to access to the close column in the Facebook stock data frame. If you are curious, you can take a look at the FB changes. Type in FB changes and then click Run Cell button. Compared to January 3rd, Facebook increased by about 1.5% on January 4th. Compared to January 4th, Facebook increased by 1.6% on January 5th, and so on and so forth. Now we are able to calculate the beta value. Let's remove FB changes. Let's create a new variable to hold the analysis result. Let's call this myModel. myModel equals to, when we calculate the beta value, we need to use the OLS function from Pandas library. It will be pd.ols, parentheses. Between parentheses, we need to specify three parameters. The first one is y. Y equals to the variable that holds the percentages of changes for the stock you want to calculate the beta value for. Let's say we want to calculate the beta value for Facebook compared to Twitter. Then we choose for y variable, we choose FB changes, this variable, because we want to calculate the beta value for Facebook, and then a comma. Next, we need to specify the x variable, x equals to the base stock's percentages of changes. After the equal sign, we need to type in a set of curly braces. Remember, a set of curly braces. Between the curly braces, let's type in two single quotes. And then let's type in a label. Let's call this Twitter. This is just a label. You can use TWTR or Twitter stock, doesn't matter. After the second single quote, let's type in a colon, and then type in the variable that holds the percentages of changes for the base stock. Because we want to use Twitter as a base stock, so let's type in Twitter changes. This is the second parameter. The third parameter is window. Window equals to a value. This value will be used to form the moving average values. As I mentioned in the previous lecture, we want to use the moving average to cancel out the influence of some special events on the stock performances. So let's use moving average for the beta value analysis as well. You can use 10 days, 30 days, 250 days, and so on. It doesn't matter. But in our data set, we only have a 104-day data. It's a small data set, so let's use a smaller moving average value. Let's use 30 as the example. Let's type in 30 after window equals to. Now our model is ready. Let's take a look at the result. Let's type in mymodel.beta and then square brackets. Between square brackets, let's type in two single quotes. Because we want to take a look at Facebook's beta value compared to Twitter, so let's use Twitter. This label we just created in the statement. And then we want to visualize the result. After the square bracket, let's type in dot plot parentheses, and then click the Run Cell button. At the beginning of this lecture, I talked about how to use beta value to evaluate the volatility of stocks. When we compare two stocks, if stock A's beta value is less than 1, that means stock A changes more steadily than stock B. When we use this rule to evaluate Facebook and Twitter, look at the y-axis. All values on the y-axis are less than 1. That means the beta values for Facebook are less than 1 when compared to Twitter. Facebook changes more steadily than Twitter. In April, the beta value increases a lot, but they are still under 1. That means Facebook still changes more steadily than Twitter. Twitter are more volatile than Facebook. This is the knowledge we can get from the beta analysis.